Hello everyone. Today I will be demonstrating a side channel attack. And if you're wondering what a side channel attack is, it's using a method to communicate or gain information from a computer system when it is not intended. And so I'll do a demonstration of that. This is a Linux terminal, so I'll open up Linux here. These were provided by Cyberbit. They provide a lot of useful labs for testing things. And we'll go ahead and make a container. Sudo docker run and we will use this. Alright, so now we have made a container. And so a container is this sort of isolated area where you can put stuff in it and stuff should not be coming out of it. If you're inside a container, you should not be able to interact with the main system. So there's a sort of isolation, right? And so you would expect that if I'm on the main system, I shouldn't be able to receive information from someone who's on the container. Okay. So let's see here. Sudo. We're going to copy a script, and this script is, if you run it, it'll stress the CPU to 100%, and you'll see why. Stress. Right. So we have successfully copied the stress script into the container, and then now we're going to enter the container. Alright, so now we're successfully in the container. So if we execute a command in here, it won't affect the main system. It's going to be exclusive to this container. So we're going to do this, and this will run the stress script. Don't worry about the error, it's running fine. And so now within this container, this stress script is running. So the CPU that has been allocated to this container, this Cyberbit container, it should be running at around 100% CPU usage. So let's do a new window. So we're going to read the CPU usage. We do sudo docker stats. You should see right now the CPU in this Cyberbit container. Oh, it was just at 2%. It just updated. Now it's at 100%. So that is from the stress script running. We took it from 2% to 100%. You might be wondering, how does this relate to a side channel attack? If you remember, we can communicate or gain information on a computer system in a way that was not intended. And so what we can do here by stressing the CPU is, if, say, we have a script on the main system that reads the CPU usage in your Cyberbit container, I could just stress and then unstress, and then say, for example, if it's below 65%, write a 0. If it's above 65%, write a 1. And so with a more advanced stress script and a script reading the CPU usage on the main machine, you would be able to communicate data from the container outside into the machine, when normally you're not supposed to be able to do that. So you'd have this secret communication. This could be used to exfiltrate data. Let's say you have the secret Coca-Cola formula, and it's an encrypted file, and so you can't really try and decrypt it on the company premise, because you would get caught with all the power you'd be using to try and decrypt it. And you can't get it out of the company premise because there's firewalls everywhere, and they're watching every move. But if you use a container, maybe you could secretly communicate that small encrypted file containing the Coca-Cola secret formula, and now you've got it out of the network, and now you can try and decrypt that file on your own machines, which are outside of the company network, and they're not going to find out. So that would be an example of how could this be used as an attack. There's also the ability that this could trigger a backdoor. For example, there might be the people who made Docker, who made the script that checks your CPU usage, they could put in a backdoor that checks your CPU usage, and if a certain pattern occurs and it reads that pattern, it might trigger the backdoor. And you might be wondering, how in the world would a backdoor show up on this Docker software? There's actually been numerous cases where, because a lot of the time these are open source GitHub projects, where a developer perhaps gets blackmailed or offered a lot of money from like a nation state actor, and they're like, okay, we need you to merge this code into your Docker processor checker, and like, don't worry, the other developers won't notice it, just merge it in there and we'll give you $1 million, or we'll let go of your family or whatever. And if you actually go on YouTube, you'll see multiple cases where these people are trying to put backdoors into the system and get it merged. A lot of them get caught, but what's really worrisome are the ones that don't get caught. And you might be wondering, why go through all this effort? Isn't there easy ways to do backdoors? The secret is there are, and in fact that's how it usually happens, right? Breaches are usually occur from much more simpler things. But sometimes the simpler things just don't work. If you want to try and, for example, if they were trying to attack a very well-defended company, they might have to use some rare method like this. And so that is one example of a side channel attack. Yeah, it's a bit spooky. So I think Control-C should stop that script. And you see the CPU just went back down. So that was a very simple script. It went back down. Just a simple script, and you can dramatically stress the CPU. You could make it very complex. And that way, at a time interval, okay, every 0.5 seconds, you either up here or down here, and then the one reading it would be writing down every 0.5 seconds. You could have it go faster or slower. There might be some inaccuracy in that, but you would overall be able to paint a pretty clear picture in this secret communication. So that is one example. There's many different examples of side channels attacks. Sometimes you're just trying to get information. Like you could be reading electromagnetic waves to try and get a password in plain text. You could, what else is there? You could be reading the processor power usage, and that might give you information on zeros and ones that are currently being written. And so that's my spiel about side channel attacks. I hope you enjoyed the video. All right. And maybe you have some interest on what happens in the cybersecurity world. Take care.